Welcome to today's training, everybody. Today we're going to do an inlay using a ShopBot desktop and the vCarve software with the inlay feature. We're going to be using Vectric's vCarve Pro or Aspire software for this demonstration. What we're going to be looking at here in this first example is what would happen if you don't compensate for the tool radius. So we have our normal job set up, and we go over here to create our tool paths. Cutting an inlay has a male and a female cut. Whether they're through or pocketed, it's still going to be the same two types of cuts. A problem that people run into is they use the pocket and profile tool paths up here, and that does lead into some problems. So I've created a profile and a pocket tool path, but to be doing that with an inlay, you're going to come into some issues that's not going to allow these to mate. So first of all, with a typical profile tool path, it is selected in this example to cut on the outside, and what would happen in that is that would leave a square corner. This purple demo can be turned on and off right here to make your tool paths solid. And as we see, this is a solid purple, a straight corner inside the purple. If we look over here, because it is a 1/4 inch cutter that we're using, even though it is a 1/4 inch down cut on both tools, you can't cut a square corner with a round bit. So that's where Vectric has added this feature here called the inlay tool path. And that's going to allow us to go in here, and the software will do the moving of the corners and mating the male and the female, or the pocket and the insert. But let's show you what this would look like out on the machine. So we can see it here in 2D that it's not going to be able to get the bit all the way down into the corner of the N, where it's going to be able to pocket it perfectly. We have our rounded corners on our C's, and we have our square corners. So let's look at what would happen out on the ShopBot itself. So here we are on our ShopBot desktop. We have a 1/4 inch down cut in, and we're just using a jig here because it's easy to switch out the blanks for this example, but any other format would have worked for a hold down. And here it is cutting the C. We're in a piece of pine. And again, this is showing you what would happen if you use just the pocket and profile toolpath, where it does not compensate for tool radius. So we have our exterior square corners on our pockets. And also notice, look how close these parts are to each other. We are not leaving much of a space in between. And then when we get down to make that final cut, even with tabs, you have the leftover pieces in between the C. So here we are now doing the pocket, same bit, same tool radius, and it's moving back and forth and carving this out. But like we just saw in the Vectric 2D preview, that we're going to have square corners and round corners. So a couple of things that we're looking at in this example are, even though it's the same diameter radius of the bit, the parts aren't going to be able to mate together. We can see right here from looking at the profile versus the pocket. You can also see the scrap here. Look how close these parts are. That's something that could come loose. Notice how the C moved a little bit. Though I broke the tabs out, the inside of it came with it, the inside of that C. So doing it this way is not going to allow the parts to mate together. One, the tolerance is so tight on the cut, and two, you have a square corner and a round corner. By looking here, you can see it's just not going to physically fit in. So this last example showed a few problems, what happens when we don't compensate for the tool radius. So let's look at how we would go about doing this correctly. So first of all, I'm going to do this out of two different species of wood, so it'll look nice. And that's kind of the purpose of inlaying. It's usually two different types of materials. Using the same size font, I just went and did a file, save as, and I'm now using this as my red oaks pieces, which is going to be the in the software, it's called the male inlay, the insert. And just to keep things original, what I can do is just move these up here so I have them for later. They could be hanging out up here in no man's land. But I'm going to bring a copy down that I'm actually going to use, or what you can always do is, control copy, control paste, or with your shortcut keys, shift and control, that'll allow you to bring one straight down and make it a copy. So you've always got shortcut keys to stay efficient with the software, and those can be found under help, help contents, and down towards the very end where it's your frequently asked questions. So with that being said, we've got our fresh thing in here. And we saw from the video too that the word CNC with the pocketed portion is fine because this is cut on the inside, but on the male version being cut on the outside of the vector, it became too close to each other and those pieces became loose, and even with the tabs they were going to snap out of there. So what I'm going to do is just move these a little bit further apart from each other so that I've got a little bit more material, scrap material, left in between each of the letters. So instead of a standard profile toolpath, which we showed earlier would leave square corners, I'm going to select the vectors and go into the inlay toolpath, where you have the option of doing a inlay that's either straight or stepped for this male portion. This one we're going to do a straight inlay, and this here would just be following through your typical commands that you would see in your profile toolpath. So there's my Z thickness of 0.5. I like to go a little bit deeper into the spoil board to make sure I get a nice through cut. I'm going to use this is the key to using the inlay toolpath function. The auto inlay will only work if you select the same size diameter for both the male and the female. So I'm going to use a 1/4 inch down cut just so I don't blow out any grain on this one. I'm going to leave it as a climb cut. Since these are going to become free-flowing letters, I'd like to add a tab to those. And we're going to give it a decent tab so that it's not going to have a chance of coming loose. And these as 3D tabs. And this one even has a name for it, male inlay 1, so we know that it's the male cut. And when we hit calculate and go, it's going to first say, hey, your material is 0.5, but you did say 0.51. Are you okay with that? So check both the decimal and the numbers. You don't want to see a 5.1 in there. And hit OK. And then here we are in preview, where we can preview the visible tool paths. Obviously in the 3D, we now see rounded corners, even though our font had a straight corner. And then back here in the 2D view, I can turn on the solid, turn on the toolpath. And using this inlay toolpath function, it was able to break that corner with the 1/4 inch radius bit. So it also broke the sharp corners, and it knows how far it can get into these corners on the inside of the end. So this is where we will go next out on the ShopBot and cut the male portion of this. So here is the first piece that we're cutting out of red oak, and this is where the jig comes in handy, because you're using several different species of wood, and it's just easy on and off with the material versus running the screws in the corner and lining it back up. So that's just an option that you can have. Notice there's the tabs that go in there to keep the C from coming loose. But now, as we saw in the toolpath of the Vectric software, using the inlay toolpath function, it's went ahead and broke those sharp corners up, and it knows to compensate the tool radius for a 1/4 inch bit. So as long as you're choosing the 1/4 inch bit for both the male and the female portion, the software is going to put the right size radius around the inside and outside of your letters or whatever it is that you're inlaying. So breaking the tabs out, you might have to sand up the tabs a little bit. If you want to stay away from tabs, you could look at different types of hold down to keep that in there for a really precise inlay. And then there's our male parts. I'd like to cut those first, and you're going to keep seeing why. File save as and call this one pine pockets, because this one's going to be out of pine. And you would change whatever size your material or thickness your material is for this. But for this guy here, I am going to just take one of these, and using the shortcut key of F9, that centers it into your material. That would also be F10 would bring up your alignment tools and center in material. And that's just how it would be on this. We'd have our inlay, and then we'd put some sort of decorative flourish on each side of this. So for this one here, again, we're going to be doing the pocketing. So we need to do it through the inlay feature, and we need to make sure if we're going to do this that it has the same tool radius so we can compensate for the way we just cut out the male insert parts. So this one's just going to be a pocket, And the material I had earlier was kind of thick for what you would normally use a pocket for. Usually you say it was thinner 1/8 inch, 1/4 inch material. You don't have to pound it as much, so you'll get a lot better transition. But for this one I had a thicker material, and it would just get a nice real strong glue joint. So we're going to cut the pocket exact depth of what the material thickness was. So the red oak was exactly 0.5 thick, so we're going to have a 0.5 thick pocket depth, and then whatever little transition might be between the two, we can sand off with the random orbital sander. So the key to this one, 1/4 inch down cut. That's what I used in the last one. Is a 1/4 inch. Make sure you have the same diameter. Select this, depending on the wood and the materials, where you'll come in and pick your type of cut. And this one here, I'm going to go ahead and hit calculate. Again, it does go into preview with the 3D. Preview what it looks like. You can switch back to 2D. You can see what you're doing with the solid view by turning that on and turning the solid preview. So a couple things that we're going to look for here is, so we see that there's the other part of our pocket that's going to stay to match the male. But something that we need to look at that you can set in either profile pocket or either inlay, male or female, and that's what we're going to look at here. And this next thing is the pocket allowance. So right now we have a 0.0 allowance, and when we hit calculate for this, it's just cutting the female version that would be mating with the male. And this is just a trick that I like to do. I like to cut out we cut out the red oak one first that had the individual pieces. Now those are sanded, those are off the machine, and they're free pieces. I like to go next and cut the female portion, the pocket. And then when that's cut, it's still attached to the table. I can take the previous cut of these red oak individual CNC pieces and try to fit them into the newly cut pockets. And if they don't fit, that's where you can go back in here and add what you would call a pocket allowance. I just found personally that it's easier to do it on the pocket or female inlay, because you have these physical male parts already out that you can fit in. So normally you would want an allowance because the machine is going to cut it so tight. For this first example, I'm going to leave it at 0.0 just so you can see how tight of a joint that it would cut. And this is something I learned early on, that there is something called good tolerances and bad tolerances. And you get bad tolerances by not having your machine dialed in, greased, and taken care of with this routine maintenance, or using the wrong bits, feeds and speeds, etc. And then there's something called good tolerance, which is where you would come in and add a pocket allowance of whatever that might be to have that fit better. So let's look at what we would see out on the ShopBot. So we can see our male parts that we had previously cut, and those are set back there. And then here we are making our first set of pocket cuts. And this one again had no tolerance. And these CNC machines are precise enough that when you cut on the inside or the outside of the vector of the same size, the part is that tight that it's not going to fit in there nice and easy. It's going to have to get beat in there with a hammer, which in that case could, rip veneers on certain types of wood. It could, blow out grain on pieces of wood like this. So we'll look at the next part of adding the tolerance so it would fit. Because right now, even with a rubber mallet and a little persuasion, I could probably get that down in there, but I'm going to mar the surface and it's not going to come back out. So this is where we would use the V-Carve or Aspire Vectric software to add the tolerance in there for us. Let the machine then cut a little bit larger. We'll cut the pocket bigger, and we can keep testing that, and that's why I like to cut the profile piece first, the male part, and then keep we just saw in the piece that's still attached to the machine.
And we can see by the
adjust the size while it's still attached.
The pocket cuts right to the edge of the vector, and the profile from earlier cut to the outside of the vector. So it's not going to fit. The machine has that tight of a tolerance when it cuts. You also need to consider where you're at in the world, the moisture content of your material, the humidity in the air, the type of material you're working with. So when you go in to add your pocket allowance, it's not always going to be the same. So practice with the scrap material and know what you're working with before you get into the larger mass production product run. A lot of times here with thinner veneers and inlays, you can get away with a small pocket allowance of 0.005. This one here being a really deep inlay, just that, again, that was the material we had on hand. I'm going to go ahead and make this a little bit larger of a pocket allowance. And again, I'm cutting the female portion out larger. The male portion, then I'll take like a puzzle piece and try to fit it in there. If it doesn't fit, I can come back and change this to make it bigger. Versus the physical male part that's already been cut out, you'd have to, how do you rehold that down now that you've already snipped the tabs off? So it's easier doing it this practice. Again, is any way that you want to do it, you can. But again, we're going to give this a pocket allowance of 0.01, meaning it's going to go out larger to the left side and to the right side of the vector. So it's actually going to be cutting out in real size 0.02 20 thousandths out. And again, that's just because I have a really deep cut for this one and to get it to fit down in there. A lot of times you'll have a lot tighter tolerance for this. So go ahead and hit calculate. You can't really see the difference in the 3D preview. So again, switch back to 2D, make your toolpath turned on, and turn on solid down here. And when you scroll in, you'll notice that this has expanded, and you're now having allowance outside of the vector on both sides. And that 0.01 and that 0.01 in this example are going to give an actual pocket that's larger of 0.02. So then go ahead and resave this, and we'll run it out on the machine. So for this example, it's going to now come back and cut out the tolerance offset that we just put in. So, normally we would know on our cut that we should build this in the first place. So it would have done this all in one cut, but just to show you the demonstration going through not having a tolerance versus having a tolerance. So now it puts it around the edge, makes it larger, and then the CNC male parts will fit better down inside there. So again, the pocket parts are cut a little bit larger. Depending on the material you're working with, the size of the tolerance that you're going to use. This was a very deep pocket, so I used a little bit larger than I normally would. First I'd want to put glue in there before I hammer it down all the way into place. And once it's glued down in there, since the pocket was cut the same depth of the thickness of the CNC red oak layers, I'm just going to glue it in there. Once the glue sets up, sand it, get a nice flush surface between the two different types of wood. Make sure you clean it off, blow it off, clean your wood, raise the grain, get it ready, and then apply your finish of your choice to it. And this is just an example of one form of inlay, where it's just using the Vectric's inlay feature. So that's a simple one, and this is where I recommend you get started. And then there's several other options that you can look at for doing different types of inlays with your CNC ShopBot using MDF. And this one going to have raised letters. And the reason I like to do it for a sign example like this is painting, having different colors. There's a texture background. If I could pull all the letters out, I can tape this off like I do in this example and spray paint or hand paint or whatever it is that you're going to do inside there. Paint these letters separate and then glue them back in place. So for this one here, it's being taped off, and then the next thing we'll do is cut or spray paint the inside of this. It brings out the texture, and then so you can see when the tape is removed. So now you have your border a different color than the texture, and then the letters still haven't been put in place. Retape it off, and now paint the border a different color. And this will now allow me to put an edge around there. And now we've got two-tone, and the letters have been painted separate, and then now those can just be used with some glue and pushed into place. You have a raised letter sign using the inlay method that we just were demonstrating. And then I just want to finish this one up by showing you the welcome sign in the Vectric file. So you can see here's just some earlier versions of getting the size. There's what the finished sign looks like. Since this was out of one piece of MDF, you could see where we used everything we learned in the CNC example. For the male parts up here, the letters were spaced further apart, so we'd have room to cut around them. Over here on the pocket, this one only being a pocket down in there of 0.2 was first of all a 0.25 pocket to get down to where the texture would be,
and that's for our textured surface. Then we get into our pocket inlay. You can see that went another 1/4 inch deep down from there. And notice the pocket allowance on this is negative 0.005, a lot tighter tolerance because I'm only pushing these letters in there just a little way, so I didn't need to have it. And I wanted to have enough tolerance that if I added a little paint to them, that it would still fit down in there nice and tight. So you're going to have nice tight pocket allowances when it comes to shallow inlays. And then finally, what we just saw out on the machine would be represented right here, and that would be what we just had looked at with the video. So this was using the pocket, this is using the Inlay toolpath with the Vectric software out on your ShopBot. To point out a couple other methods of inlays, definitely check out the Vectric's website where they do one with a V-carve inlay. And this one's really nice because it allows you to have crisp corners instead of having the typical inlay feature where it has to have a radius corner. This one allows you using V-carve to get nice straight corners. So this is a really nice one to do. Enjoy the results from this. Another one that I'm a big fan of for doing inlays, and this is with veneers, thin veneers, is the Donic tools. He has a Donic drag knife, and there's several different models of this knife for different thicknesses of materials. So if you're going to get into doing a lot of veneer inlays, definitely worth a while to check this website out and see the product because it works great for that. So as you can see, there are several different methods for inlaying. I'd start out by messing with the inlay feature in VCarve Pro or Aspire, and then start knowing your materials and the tolerances of what they could be, and then start looking into some of these other ones. The VCarve inlay feature is really nice and is able to get the nice corners, angled corners that you want. But thanks for checking in on today's training, and there's plenty more trainings coming this year. And again, our website is also a very useful resource tool between the different documentation, trainings, and videos, projects that are on here. The forum is a good place to ask questions for other ShopBotters. So thanks for joining in with us, and until next time, we'll see you. Thank you.